Hey guys, I'm starting to do some restoration work on my Philco 7008 with the hopes that I can try aligning a TV or FM radio with it someday. Since I last left off, I got a great suggestion about how to get this AC line cord plug opened up. I tried unscrewing it as best I could with just my hands, and I couldn't get it apart. And I got a great suggestion to heat up one end of it and also stick it into the socket or into the plug to get a better grip on it. And that's all it took. I didn't even need to heat it up. Once I got it in there, and with this knurled outside, easy to unscrew it. So now I will have no trouble splicing in new line cord. That's cool. Let's see, also I discovered there was a 5V4 tube in here in place of the original 5Z4 metal tube. Well, that's actually cool because 5V4 G types are kind of hard to find or expensive, but 5Z4 metal tubes are more common. So pop this out, which is often used as the damper tube in some of my early TVs. Much rather use it for that and stick a 5Z4 metal tube in here. Right now I'm working on getting off this bit of metal here so I can see what's going on with that capacitor. If you recall, the parts list does not list the voltage ratings for any of the capacitors or the wattage rating for any of the resistors. So I'm having to physically examine them. Now it seems like all the paper caps I've checked so far, 630 volt will be more than adequate. So I think these I'll have no trouble with. But the electrolytics I want to double check, especially the ones like that one that are part of the CRT circuitry. They might be higher voltage. Something else I discovered is what this front panel is made of, because I tried cleaning it and it did not go well. What I ended up doing was finding out that it's copper, nickel-plated copper to be specific. So this green here, which I tried cleaning off, is actually some nickel corrosion, I do believe. So what happened here was it was a green splotch. I tried using some navel jelly, instantly turned to copper. So I don't know what kind of chemical reaction was going on there, but boy, it just immediately took off the nickel, it looks to me. And over here, I tried using some metal polish. Went right through the nickel layer, so it must be quite thin. Which is a shame because this is a nifty looking front, but it is really dingy. So what I'm researching on doing is replating it, or at least touching it up. I can get a nickel plating kit from Caswell. They have several types. More elaborate, it'd be a few $100, but it's a full submersion tank to do nickel electroplating. But I think that's a little overkill for this. What I'm more likely to get is a little bottle and then do some brush plating, just some touch-up. For the most part, it looks pretty good. I'll try just lightly polishing. I've seen a lot of suggestions online about how to clean and polish nickel plate, from just doing a light cleaning and then possibly vinegar or ammonia. You definitely don't want to use anything aggressive or this will happen. Now, one thing in my favor is that it seems like plating copper is one of the easier things to do. If it's other types of metals, you might have to do more prep work. But if I can get some nice clean copper and get that brush-on solution, I think I can just redo the areas that need it. So in areas where it's really corroded like this, I'm inclined to just go with like the navel jelly and just take it down to the bare copper in a larger area, and then just plate that up. And down here, they painted over it, kind of like to retain as much of it as possible. But I have seen, I think it was on the Antique Radio Forum somewhere, I couldn't find the thread again, where somebody took something like this, took it down to the bare metal and redid the whole thing, and the final results were spectacular. So you get this all down to bare copper. Maybe send it out to get professionally nickel plated, and then this you can do with like rub-in lacquer stick. I have black and red to get the color into the recessed lettering, and then down here get some hammer tone blue paint. So I don't know, maybe if I get this working really great, and it works really well for my TVs, and I feel so inclined, I might go that far. But let's get this thing working first. So a couple more screws to take out here, then I can take a look at that. This candome resistor on the other side, I noticed when I powered this up, it didn't seem to get warm. It does appear to be open, but I have not figured out yet on the parts list what it is. Because again, they don't have the wattage ratings. If they did, I would look for something like a 20-watt resistor, and that would very likely be it. But just from looking at the schematic at the parts list, I have not quite traced out the circuit yet to figure out what this guy is. Because if you recall, the audio isn't working, the 400 hertz range, and I think that's up in here. So it could be some leaky paper caps, could be this opened resistor, or both, causing some of the functions to not work properly. I think I've got all the screws out that were holding this in, so take a closer look behind. Alright, now I can get down in here and clean. This metal surface is cleaned off, and get in here and check out all the circuitry. The CRT is rather dim. I have to put the intensity up all the way to get a nice bright trace, and that's what this stuff is all about. And I bet some or maybe all of these resistors have drifted up in value, which could be throwing off the voltage divider. And get this capacitor too. Kind of did me a favor by having these long leads so I can pop it out. Aha, there is the one I was most curious about. 475. Not so easy to find a capacitor rated for more than 450 volts. So what it could do is like take two 33s and put them in series, like two 33 microfarad to 350 volts, which would end up being like a 16.5 microfarad rated for 700 volts. Or you can get 5 and 600 volt rated electrolytics, just tend to be expensive, and your choices aren't as good. What I want to try doing is, let's see how leaky this thing is. Because this is filter cap on the high voltage. And if this is really leaky, you might be pulling it down, which would account for the CRT not being so hot. Okay, I got my solar capacitance bridge fired up. Let's see what we get. Check for leakage first. It's a bit leaky, but it seems like it is warming up. So on 400 down, it's good, but get up to 500. Alright. Let's check for capacitance too. That seems... that's okay. Right about 15, like it's supposed to be. So if I leave this sit long enough, it may from up to the fully rated voltage, but I plan on replacing it anyways. I was just curious if this thing was like fully open or a dead short, it would certainly be affecting the CRT performance. But as it is, it's probably doing an okay job of filtering the supply. Might be dragging it down a little bit though, because it is a fairly low current set. These are mega ohm resistors in here, so if this is even slightly leaky, it could definitely be dragging down the high voltage. When it's not high voltage, it's not running at thousands of volts. It's running on, I think, 400 and something volts. Well, I've got this bridge fired up. How about we take a look at a few of the paper caps. Selected 3, clipped out one end, so they're out of circuit. All of them should be rated for 400 volts. And what I suspect is that all 3 will be very leaky. Look at that, leaky at 100 volts. These do not form up like electrolytics, so they're only going to get more and more leaky over time. Alright, one bad. too bad. And this is why I don't bother testing paper caps, because they're always bad. And that one is leaky as well. And this was a precision piece of test equipment at the time, so you would presume they used the best components they had available, and still no good over time. Time is not kind to paper caps. I figured I'd start working in this corner. All these paper caps need to go. It's very accessible. And there's a handy diagram in the service info that shows that same area with all the components labeled. So we've got C301 through C305. It's 1, 2, 3, 4, and a fifth I just clipped out up here. All the same, 0.1 microfarad. I'm going to be replacing them with these guys. And while I'm doing that, I figured I'd check the resistors too, and the findings are pretty grim. This is a 100K resistor buried down in there, measuring 152K, so 52% high. Let's check out this other 100K. 236. I'm finding similar resistors way off in the same area. So while I'm replacing all the caps, I'm just going to go ahead and replace all the resistors. And I'm going to use metal film precision resistors. Very accurate, very low drift with temperature. So between the new caps and the new resistors should be a very stable circuit. And what is this circuit? This is the vertical amplifier, first stage and output. And right opposite the vertical gain control, which as we saw is very, very dirty. So I'll shoot some deoxit down in there. Easy to get at with these components out of the way. There's a gap in there. Shoot some deoxit, work that control back and forth good. Circuit should be working much better. And I'll test the tubes while I'm at it. Oh, and also this guy here, that is the audio oscillator, which does not appear to be working. I'm guessing it's because these resistors are way off, or because this cap is so leaky. I finished recapping this area, which is a vertical amp, and I thought that was the audio oscillator, but no, it's actually the blanking circuit. Now I want to get in back here. In order to do that, I'm going to have to move this. Luckily, it looks like I just have to take out 4 screws, and this will swing out of the way. And this candome resistor, which I thought was bad, is actually okay. So, looks like I've got 5 paper caps buried down in there. I also sprayed some deoxit into these 2 guys, and once this is out of the way, I should be able to get the other 2. So I hope doing all that will make this circuitry work better. So the vertical lamp was very touchy before. Oh, and also going to test these tubes while I've got them out. A couple Lochtel 7F7s and 6C4. Well, it was almost as easy as I hoped. I had to take those 4 screws out and disconnect a wire that ran down through this insulating sleeve down to this lug. Just pull the wire out, the swings completely out of the way. Now I can dig down in here. And as I'm digging into this, I'm finding that it's actually remarkably clean. I imagine this is cadmium plated, and no signs of oxidation. Just some fingerprints here, which may very well be from me. There's oil on my fingers reacting with whatever this metal is. Well, things aren't looking so good, at least not for this 7F7. One section is about 43, definitely in the replace zone, and the other one is way down in the replace. Let's see about the other one. I rarely use Loctile tubes. I know I've got some up in the attic, so I'll have to go dig them out. Hopefully I got some 7F7s. Ugh. Wow. Yet, this thing seemed to sort of function. This section of the tube isn't that bad, but man. Both these tubes have one triode section deep into the replace. See, this is the two-stage vertical amp there. Push-pull. Complementary, so just mirror circuits of each other. Ends up driving each side of the vertical deflection plates there. So I would imagine replacing both of those couldn't hurt. And let's see, 64. And these are all Philco branded. Very probably the original tubes with this, and this thing was just used and used with those tubes in it. Well, I dug up a couple 7F7s, but they're both used. This one, not so good on one side, but the other side is good. So, I suppose it's better than what was in there, but I'd still like to find some better. I think I probably got them. I have not sorted out my octal and loctile tubes very well, so it's hard to find them. Let's check out this guy. And I also found a very nice looking 5Z4. Just remember somebody stuck a 5V4 in mine, but this is what's supposed to have these metal 5Z4s, and this one looks like it could be new old stock. I'll test it first. And then, if that 5V4 is good, I can use it in my TVs or damper tube. Well, this one's got a little leakage, but one side's good. Yeah, both sides are good, and the leakage is low enough it's still in the green, so I think this is a winner. Let's check the 5Z4. And nuts. No card for it. Oh well. Let's pull out my Cox 600 to test it. Alright, had to pull out the Cox 600. Pretty hard to find one tube tester that will do everything. HR06 000. It's the only socket I can go into. Alright, and P0, and 65, and we push P3. I have a feeling it would be good. And the other is 0, 4. Cool. Definitely use this guy. I finished recapping this area, and I popped in the 5Z4, and I got it powered up, and I'm trying to figure out why the audio oscillator isn't working, which is this guy down here. There's not much to it. Transformer, one resistor, one capacitor, which I've replaced. I've been poking around with the probe, not getting any signal. I noticed something. That tube does not appear to be glowing, so I think it might be as simple as I need to replace the 6C4. Well, the tube checks out okay, and I tried another one for the heck of it, but no improvement. So it got me thinking, should take a closer look. Now I did measure the voltage in the pins. It's definitely 6.3 volts AC on the filament. Ah, there it's glowing. either a dirty tube socket or a damaged pin perhaps. Oh, also something else, I took cover off the CRT so now we can see it inside of its little swingable housing in there. So this can swing up like this. It does that via flexible cable. It goes down through the pivot hole down in there. Kind of hard to see where it goes, but they took all the leads off the CRT, bunched them together, put it inside of a sort of like a protective sheath, and run it down through a hole right around where this thing pivots so there's not too much strain on those wires. Alright, now let's see if we've actually got 400 hertz signal. I'll just clip it right here on the tube. So let's try right there. Hey, look at that. Nice, a big, strong signal. And it's actually too strong a signal for the scope to handle. See the smaller amplitude. Yeah, this looks a little bit better. Alright. 398, close enough to 400 hertz for me. Alright, looks like that feature is working again. But you can't rely on the tube keeping good contact there, so I'll pull it out, spray some deoxit into the socket, work that tube around good, and see if I can get it to function when it's pushed in all the way like it normally would be, like so. You can see the filament's fading out. And we're going to lose our sine wave. And there it goes. I shot some contact cleaner right into the socket, put the tube in, wiggled it around, pulled it out, wiped off the pin, stuck it back in, and now I've got filament continuity in all positions, including firmly seated. So I think that little problem is taken care of. Alright, so what else? Well, I still need to do work in here. Some of these resistors are way off. That's a high frequency oscillator. And I'm going to have to start finding a way, figuring out a way to get down in there and down in there. And I want to get this stuff as well. It's fairly easy to get to. Not so much. Now, one nice thing about this device is that it's all put together by screws, no rivets. So just like I took off this part and swung it to the side, I can unscrew all these various compartments. Well, I have to disconnect a few wires here and there. So like to get this thing out of the way, take off these two screws, put this out of the way, and then get these screws, and then take this whole assembly away. And maybe I can get down in there. Don't want to mess with this stuff too much though. Let's band switch for the marker oscillator and the marker oscillator itself and the crystal oscillator. All that stuff's working. So I don't want to disturb it, or I'll just have to go through and recalibrate it. And I really want to replace that filter cap too. It's going to be the hardest thing to get at. Oh, I see there is a So it's held in by a clamp. If I can loosen that up and clip all the wires off, I can get it out, but putting it back in might be a little tricky. Well, I'll work on it. I'll probably end up having to take some of this stuff out.